Hey everyone, welcome back to a special edition of the LlamaIndex webinar series. Today is going to be a super exciting edition. We're joined by some folks from Google Labs to present some multimodal and advanced RAG use cases with Google Gemini, plus LlamaIndex. And so we're joined by Lawrence, Michael, and Cher on the Google Labs team. And they'll go first and they'll present a little bit, I think, about the semantic retriever and how to build advanced RAG with LlamaIndex components. And then Hao-Tian and I on the LlamaIndex side will present a short workshop on how to build multimodal use cases with Google Gemini and LlamaIndex. And so we're super excited. This talk will be recorded, uploaded to our YouTube channel. And without further ado, let's take it away. Awesome. Okay, screen share works. And Cher and Lawrence and Michael, I'll let you take it away.
Yeah, good morning, everyone. My name is Cher, and Lawrence and I from Google Labs, and today we are going to present to you about advanced RAG with LlamaIndex and Google Gemini. So this presentation will really cover RAG use cases for both simple and advanced users. First, we will start with a short introduction to a simple RAG pattern for context setting, and then we will talk about Google's developer RAG offerings. And then beyond simple RAG pattern, we will introduce to you a few advanced techniques that you can use to really customize to your use cases and improve quality, and then we'll move on to a short demo. First, we'll start off with level setting with introducing the simple RAG pattern. There are 3 steps to the simple RAG pattern. You start with the document. First, you have the ingestion phase with embeddings and vector store. Then you have the retrieval step with given a user query that in the vector store, and then feed it to an LLM for response synthesis to arrive at the answer. And this is the canonical pattern that's very well documented on LlamaIndex documentation. Google recently launched a few offerings in this RAG pattern realm. The first one covers the ingestion and retrieval step with the Google Vector Store, which is a name in the LlamaIndex code base. All of these is integrated with LlamaIndex. And this is what we call the General Language Semantic Retriever API. And it covers the embeddings and vector store use case with built-in embeddings model. Next, we also have the response synthesis phase, or we call it the AQA model, which is the response synthesis with the LLM to arrive at a grounded answer. We'll go into this in a bit detail later. But for users who are looking for a simple RAG use case, we actually packaged both the Google Vector Store and Google Response Synthesizer into a single managed index called Google Index. And we encourage users who are just looking for a really simple out-of-the-box solution to look into the Google Index as a single object they can use to perform the simple RAG pattern. And now I will go into what the offerings Google Vector Store and Response Synthesizer actually are. The Google Vector Store is the general language semantic retriever. It comes with the managed vector database and embeddings. It is designed to be simple with text in and text out and metadata filtering. It's ready for production for flexibility and ease of development. It's important to note it's optimized for small corpora of 1 million chunks, which, to give some context, is about 2,000 novels, assuming 85,000 words per novel, and 250 tokens per chunk. And it's also secured and privacy by design, with the corpora shareable to other developers through OAuth. And this is, to repeat, the use case for the first 2 steps. And the next step is in the RAG pattern. The next step is the response synthesis. And for that, we launched last week the AQA model. AQA refers to attributed question answering, which for people, you may know this as the open book question answering use case. A few features we want to highlight with the AQA model is that it provides grounded answers, attributions, answerability, probability, voice styles, as well as safety settings. I want to double click a bit into some of these to introduce you to what these features really mean. Started with grounded answers. Grounded answers means that the AQA model attempts to give you an answer that is grounded in the context that you provide. If a response is, by the word that the response is grounded, it means that the answer can be verified by the context, and that external world knowledge that's not provided by the context you explicitly provide to the user, to the model, is not used, except for things that are really common sense. The model provides where the answer is grounded to in the attribution, which is a subset of input context used to generate the answer. For example, if 10 passages are given to the model and only 2 are actually used in the response generation, then only the 2 passages will be part of the attribution. So it really lets you know where the answer is coming from. It is as much as it's important to know in cases where the answers can be grounded, it is equally or perhaps more important to know when the response cannot be generated by the passages provided. And that is why we provide the answerability probability, which solves the I don't know problem. As many of you may know, language models may hallucinate when it does not know the answer, but tends to generate an answer anyway. And sometimes in RAG use cases, the question cannot be answered from the context or from the document you provide. The IDK, or I don't know problem, comes down to recognizing these cases and to provide that information to the developers. But what about gray areas? What about questions that can only be partially answered, or there's no definitive answer to whether it can be answered? That's why we provide in the model answerability probability, which is a number from 0 to 1. This is the model's estimate of a probability that the answer is correct and grounded in the input passages. So that gives the developer, as the final decision maker, to choose what are the behavior to expect, or the behavior to give to the end user, given the answerable probability. So to repeat, the model would always tend to generate the most grounded answer that it could, but it also provides an answerability probability from 0 to 1 that gives the developer the power to choose what to do. What does this really mean? What it means in practice is that if the answerability probability is 0, then it means the model is extremely not confident in the answer. And answerability probability of 1 means more confident in the answer. There will always be an answer, and the model will not explicitly say, I don't know, but the way it indicates to the developer is to generate a low answerability probability. We recommend the cutoff score to be about 0.5 for how to give the response to the user. This is a best practice. The point is that the power is in your hands to decide what is right for your use case. But for most use cases, we recommend a probability of more than 0.5 indicates that the answers are more trustworthy, and tend to recommend developers to show to users directly, which is in this area. If it's lower than that, most applications, we do not recommend showing these to the users. What you can do is 2 cases. Either fall back to a general LLM that relies on world knowledge, that is knowledge outside of the given passages, or display a message to the effect of, we cannot answer that question based on the documents. So this really gives you flexibility to choose. And to further illustrate how the AQA model solves or counters the I don't know problem, we look at the evaluation of F1 metrics as defined in the Squad V2 paper. The Squad V2 dataset is the Stanford question answering dataset that is used in a lot of research to look at the quality of question answering. And we run the evals on our models as well as look at the Llama 2 F1 score, which is taken from their paper, and they reported this. The F1 score captures the precision and recall of the answers being generated, as well as the exact match score, which is how many questions are exact match to the standard answer. And as we can see, the AQA model compared to a general purpose model has a much higher answerable F1 score, which means when the question asked cannot be answered by the documents provided, it is much better at saying, I don't know, in the form of giving a low answerability score. And as a result of being able to say that I don't know to questions it cannot answer, the overall F1 score is also much higher than a general purpose model. Okay, so this is the feature I really want to highlight, the AQA model, because being able to say, I don't know, or to punt is really important. Besides that, I also want to mention a few other interesting features of the AQA model. For example, the voice style. It offers 3 different kinds of answer voice style as input to the API so that you can choose what kind of answers the model will answer it with. The first style is extractive. For example, given the questions, why is the Red River named the Red River, it'll just give a very simple phrase as an answer. Abstractive is a bit longer. The answer is the Red River was named for the red bed country of its watershed. Finally, this is verbose, which is a very chatty model that includes a bunch of extra details. For example, the Red River is named for this. It is in this region. The rock is formed due to the accumulation of sediments, etc. So this also gives the developer the ability to be flexible and choose what they want for their application. I also want to mention the safety setting, which depending on the application, you can choose the threshold. For your own product use cases, you can define what constitutes as good content and align with the goals of responsible generation. Yeah, here are an introduction to the simple RAG pattern, as well as what Google is offering in this RAG use case integrated with LlamaIndex. Now, beyond this simple pattern, there are also a lot of other advanced techniques that you can use to really tinker around and increase the quality or customize it to your use case. There are many, many techniques you can use, and actually LlamaIndex provides a lot of good examples for these. And we want to share just a few of these advanced techniques with you, and as well as go to a technical deep dive into the RAG use cases. I'll hand off to Lawrence for this section, and you can share your screen, Lawrence.
Okay, thank you, Cher. Let me share my screen. Hi, my name is Lawrence. I'm going to be going through some of the technical deep dive. So if you have a very simple use case, you can just use the Google Index, right? So here's a quick example of how you would set it up. So the first thing you would do is you will create a service account using your Google account, and then you would just use these 2 lines of code to establish your credential. And then you will create a corpus in the Google Index. A corpus is a collection of documents, and the documents can be split into smaller chunks. And once you create your corpus, then the rest of it is just LlamaIndex code. Right here is you use LlamaIndex simple directory reader to ingest a bunch of files from a directory, and then you just insert it into the index. And then you could just create a query engine, and then you could just immediately ask the engine some questions. Now I want to go into the response here, right? So our AQA model does not just give you a text response, but it also give you the attributed text. These are the passages that were actually used in the constructions of the answer. And then lastly, we also provide the answerability score this is a number that Cher has talked about between 0 and 1. Now, I want to get into a little bit detail about how you can configure the AQA model. In the slide before, right, in the query engine, we didn't pass any parameters, so you were using the default, and we have some sensible defaults for all these settings. But if you want to, right, you could change these settings, right? Some of the settings you could change is the temperature, the answer style, and also some of the safety settings. Now, the basic web pattern has some issues, right? If you want to take it to production level, I'm not going to go through all these problems. LlamaIndex has very good documentations on addressing each of these issues and many tools to address them. What I'm going to go through is 2 of the techniques that we've found very powerful when you use it in combination with our AQA models, and would like to share that with you. Right. The first technique is breaking down your initial query. So suppose this is the user's query, right? Who was the college roommate of George Washington's wife and Thomas Jefferson's sister? Right, so this is a very loaded question with a lot of sub-questions that could be broken down. If you just use this query to get some retrieval, you're probably not going to get some very good results. So what would be better is if you could break down this complex question into smaller, more focused question so that you could get some answers. Like for example, right, you could break it down to who was George Washington's wife, who was Thomas Jefferson's sister, and then you will get back some response. And then you could ask a second round of questions, right? Who were ex's college roommate, whoever the George Washington's wife is, and then there are questions about Jefferson's sister, right? And so the idea here is that you want to have some focused queries for better retrieval. And then you're going to combine it. And in LlamaIndex, right, this is how you would do it. Right, the first few lines of code is the Google specific stuff where you would like create a corpus or just use an existing corpus, right? And then you establish your AQA model, right? And then here is the rest of it is the LlamaIndex multi-step query engine, right? Now, the model that you use to break down the question here, we're using Gemini Pro, right? You could use other LLM too. So this is the other LLM that you use to create these sub-questions. Another technique that we found very useful was re-ranking. So let me just briefly explain what re-ranking is, right? So typically you would just embed documents transform them into factors, and then put them into factor store. And then when a question comes in, you will also convert that question, the textual question, into another factor, and then you would just pair match based off the numbers in the factors. But the problem with this approach is that the embedding is a lossy process, right? You lose some information, right, when you reduce them to factors. We do this because comparing factor is very efficient, and that's why we do this, right? So what re-ranking does is that we wish we could just take the original question, pair with each of the documents, and then get a relevant score, and then based off that, right, then we will pick the passages that has a high score, right? But this is a very expensive process, right? If you just compare, if you have like 1 million documents, and then there's no way you could just compare with each of the 1 million documents, right? So re-ranking does the middle ground, right? So the first step is you still retrieve some of the passages, but you retrieve a little bit more, n plus m. And then you do a second round where you then either employ an LLM or use a dual encoder to actually match the textual information in the question and the textual information in each of the retrieved documents to compute the best relevant score. And then you return the top n. Right? And this is how you would do it with LlamaIndex and now AQA. Right? Again, the first part is Google Index code, or Google code, and then you establish some parameters with AQA model, and then you use LlamaIndex LLM RAG. So LlamaIndex LLM RAG uses an LLM to provide the relevant score, to provide the relevant score based off the questions and the answer. And in here we're using Gemini, and then you have it. Okay, so lastly, just want to say you could actually combine these techniques. You don't have to use one of them, and this is a combination that we've been using at Google. So you have a source here, you would chunk it up, and then let's say a user question comes in, you would then do this multi-step query rewrite to break them down to sub-questions. And then you will use factor search to retrieve some of the chunks, some of the passages. and then you will use a re-rank the steps, right, with either a dual encoder or LM to pick the best passages out of it. And then you produce, and then you use our grounding model, right, the AQA model that we use to make sure that you take the sub-questions, you take the retrieval, and then you produce a partial response. Now, if this partial response is a full response, you stop there. If not, you feed it back to a context, and then you do a round 2. Right? Now you pick the user's question, pick whatever you've learned so far, you ask the next set of sub-questions, and then you repeat a few rounds until you get a full response. Right? So again, so this is an ingestion, right? So the bottom left here is the multi-step query rewrite, and the top here is the re-rank, and then here is the response synthesis using Google's AQA model. And here's how you set it all up. So just a few lines of code. Right? Again, you set up the Google Retriever and the AQA model on top, set up the re-ranker here in the middle, set up the multi-steps query writer here, and there you go. It's not a lot of code. Okay, and then now here, I'm going to see if I could like run a demo for you. So here it is. So first, I just want to show you the difference between Google AQA and if you just use web-based of Palm 2. Right? So I'm going to first just upload a file. I'll upload the program essay. Okay, so I could ask these questions, right? What were program's achievements? Let's see what happens. Okay, so AQA model came back right away. Okay, so this is the Palm 2 model. So in the Google Palm 2 model, it just said, okay, he gave a talk at Lisp conference, and that's it, right? Nothing more to it. Now in the AQA model, right? So it has a little bit more substantial response, right? Or a book, work on some filter, painting, and then, yeah. Now here is attributions, right? Here are the passages that were actually used to construct this answer. And here's the answerability probability. So 1 is pretty high. So meaning that for this question, the Google AQA model was very confident that it produced the right answer based off of these retrieved passages. Right, so here it is. Now I'm going to ask a question that is not in the essay. Who did Paul Graham marry? So let's see what happened. Okay, so now in the Google AQA model, it says no answer. Right? It did post some passages, but it could not infer the answer from it. So it returned a probability score of 0. It just could not do it from these passages. On the other hand, Palm 2, I don't know who Jessica Livingston is. It could be like from the parametric memory that it has. So I don't think it's in the essay. Let me just check. Right? So this is the actual essay. Let me see if I can find this name here. So there is, yeah, so there is her name in the passage, but I don't think this is his wife. Yeah. Okay.
It is.
That's his wife? Okay, cool.
Yeah.
Oh, okay. Yeah, so yeah, I wonder what happened here then. Okay. 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 Now let's ask another question. What was Paul Graham's childhood toy? Let's see if it has this answer here. Okay. So here, Google AQ actually came back with this. I guess this is the passage about how he took years of nagging his dad to buy him one. Now, the probability score is pretty low, so I guess the model wasn't so sure if this was a toy, I suppose. Whereas the Google Palm 2 said unanswerable. It couldn't answer it. Okay. And then the last thing I want to show you is a complex question, but that uses these techniques. So I'm just going to delete all the files. I'm going to choose this markdown here. Okay. So what happened is I'm loading a bunch of biographies of some cartoon characters that some of you may know. And now I'm going to ask the questions, right? So if you guys know Peppa Pig, I'm going to say, what was Peppa's father's son's favorite toy? Right? So a question like this, right, could not be answered in one retrieval because it could like take multi-steps, right? Who was Pepper's father? Who's his son? What's his favorite toy? And let's just see what happens. So Google AQA couldn't answer it. I retrieved 2 passages, but that's not enough information to answer it. Now on the right-hand side, it's doing the multi-query, breaking down the questions into sub-questions, and then let's see what it comes back with. So it said like, George picks favorite toy is a dinosaur, which is the correct answer. And then we could even see what question it asked, right? Like it asked like, who was Pepper's father, right? And then here's the answer, right? And then it was able to ask a second question and then be able to answer this, right? And here's the passages that it pulled back, the biographies, and then came back with an accessibility score of 99%, which is pretty high. Yeah. So yeah, so that's the demo that I just want to show you. I'll hand back to Jerry.
Yeah, actually, if I can just answer a few questions from the chat that's commonly asked. There's a question where the answerability probability comes from. So that the AQA model is trained to generate the probability in addition to the answer and the attribution. So that's where it comes from. And there's a question where, like, in one of the examples, the answerability probability is 0. How to use that information, right? How much to trust the answer and attribution, given that's the case. So the answer to that is that the AQA model would always generate a response and attribution, but it will also generate the probability to give you context into how confident the model is about this response and attribution. The number is like 0 or 0.01. It basically means it's not confident. And as a developer, you can like choose what to show to your end user in that use case, right? And in one of the other examples regarding the wife, it shows that the AQA model won't answer based on broad knowledge or based on parametric information that's not in the document that you will provide. Yeah, I know we're out of time, but lastly, I just say the model is in beta and it's free to use. Yeah, hand it back to you, Jerry.
Great. Well, thanks, Cher and Lawrence, for a fantastic presentation. Hopefully, the audience has learned some aspects of building advanced RAG and retrieval with the kind of retrieval API along with LlamaIndex components. And so as the next step for the second half of this workshop, and also I realize I think we might not have time to get through all the questions. And so if that's the case, please feel free to hop on the Discord, leave comments in the eventually uploaded YouTube recording, and we'll definitely jump in to help out. And of course, these slides and materials will be shared afterwards as well. And so with that said, let's jump into the multimodal RAG section, which I think many of you are probably pretty excited about with the kind of the Gemini like Pro Vision model. And so we'll first just go through some basic slides on talking about multimodal RAG use cases kind of at a pretty high level. And then Hao Tian will give a demo of some of the multimodal use cases we've actually directly worked on with LlamaIndex along with Gemini. And so the notebook itself will be shared. These slides will be shared as well. And so hopefully you'll learn some things along the way. And so the agenda for this set of slides is really, first we'll just go over a very brief introduction of the Gemini Pro Vision model. Then we'll kind of talk about what it really means to do multimodal RAG, which is basically, everybody is familiar with RAG. How do you actually generalize this to the multimodal setting, and what does that really mean? And then we'll kind of talk about some brief additional use cases like structured data extraction and image captioning. Great. So let's start with the Gemini Pro Vision model. The high level change, right, and I'm kind of really simplifying things here, is that the input is not only just text, but it's also text and images. And so we kind of added these integrations in collaboration with the Google Gemini team into LlamaIndex, and it supports both a completion and chat-based format. In terms of the completion format, you can effectively just pass in text and images with separate arguments. In the chat-based format, you can interleave text and image messages to basically kind of generate like a conversational structured set of dictionaries, and then the output is text. And so in the example notebook, for instance, we have this screenshot of a street in New York and identify the city where this photo was taken. So you take both an image and text prompt, you feed it into the Gemini vision model, and you get back an answer. This is an alleyway in New York City. It's between two tall buildings. There's a bridge. And the other aspect here is, in addition to kind of supporting both completion and chat, we actually support basically async and no async, as well as streaming and no streaming. And so you can actually stream your responses back in addition to kind of doing things in a blocking fashion. Of course, by the way, we also support just the Gemini LLM, right, which is text in, text out. And that also has support for completion, chat, async and streaming as well. And so I would definitely encourage you to check both these models out. So at a very basic level, we have the LLM abstractions, and that's just kind of the core building blocks for building these use cases. Okay, so now let's talk about multimodal RAG. As multimodal models have kind of grown in popularity, and some of these exciting releases like Gemini have come out recently, we've thought about like new opportunities to actually leverage these models in building RAG. And this includes kind of a few different aspects. One is on indexing. How do you actually, index both text and images? How do you actually do query and retrieval on both text and images? And how do you do re-ranking and synthesis? So on the indexing side, right, you can kind of think about this in two ways. You can index images and text, and you can index them in different ways. You can generate native image embeddings. You can extract out structured text from images to actually use a multimodal model to extract out text and then index that text that references the original image. On the query and retrieval side, you can do text-to-image retrieval. You can do text-to-text retrieval, of course, that again links to the image. You can do image-to-image retrieval. And so basically any tuple of text and images, you just swap out anything that used to be text with the tuple of text and images, and then there's like some number of combinations you can do. And of course, you can also do re-ranking and synthesis with both text and images to try to improve the final retrieval quality. Here's maybe like a nice diagram that Chen put together to basically illustrate how this works. Given some input set of documents that are inherently multimodal in nature, this could be an archive research paper, this could be an SEC document, this could be basically a Medium article. You factor out the text as well as images. And you have some sort of generic text encoder to basically generate a set of embeddings. You have some generic image encoder to generate a set of embeddings. And then along with any sort of embedded objects, you have some sort of like table encoder or chart encoder to generate a set of embeddings, right? And we're talking about encoders in a pretty generic way, and we'll talk about specifically what it means to do image encoding. And so in terms of the storage system, you can store these text, images, any sort of arbitrary objects in a vector store, like if you have embeddings associated with it. And of course, the raw objects like the images can be stored in blob storage, right? Like in some sort of object store that's like a key value store that's in addition to the vector store. Okay, so let's talk about image indexing. Given an image, what are the different pathways to actually store and index this? So one is you could, and this is the pathway we'll actually show with Gemini, take the image and extract out some structured text from it using a multimodal model like Gemini. So you extract out some text, index the text embeddings, and store a reference to the underlying image. This actually turns out to be quite effective in a variety of ways because it gives you a lot of flexibility in extracting out not just a summary, but actually an entire structured output. And we'll get into that in just a bit. And this allows you to both retrieve based on embeddings, but also potentially retrieve based on like a structured query. You can also, use an image embedding model to generate an image embedding and to just a native image embedding and put that into a vector store. We won't cover that today, but basically there's multiple ways of kind of trying to index an image and retrieve that image based on different types of generated embeddings. So now on the multimodal retrieval and generation side, we can talk about, okay, so now your data, like text and images, is stored in some sort of vector store, doc store. So now given some sort of query, you want to get back a response. And here, there's different ways that you can have both text and images in this pipeline, right? And so first, the query can be either text or images. Text is just your standard kind of RAG lookup. Image could be kind of like Google reverse image search, right? Like you want to input some image and you want to find relevant images to this image, or you want to actually kind of find relevant text to this image, right? And so the query format itself can be different. You generate a query embedding And then you go into your storage system and do retrieval to return the relevant images and text. And again, this is based on kind of the inherent embedding you generate that references the image and text. From here, you basically fetch the raw text as well as any sort of images from blob storage. And then given, now you have a set of retrieved images, retrieved text, and now you can try to synthesize a response. And of course, there's also different ways to do this, right? You could just synthesize the response over the raw text and just return the images itself as like a list. You could feed in those set of images as well as text into a multimodal model to actually generate like a response across both the text and images. And so basically you have a choice of kind of returning or basically feeding in either the text and images as input or just the text. And the response format can be, the final text response plus a list of sources, which are again multimodal. So there's a variety of things that you can do here. And this kind of dives a little bit deeper into like the indexing process, like leveraging multimodal embeddings, right? And so during the indexing process, when you actually feed in an image, for instance, you could use an image embedding to basically index that image natively, which again, we're not going to cover during this webinar, but there's different types of embedding models. And I think more specifically for this, you can actually leverage multimodal models to extract structured text from the image. So multimodal models have a pretty strong table, chart, and image reading capabilities. And so you can extract out some sort of structured dictionary, generate some sort of like structured text description plus other attributes. And so basically given some sort of input text prompt plus the image, and generate this like structured metadata dictionary, and then generate text embedding. And this is the thing that you actually store in the vector store. And Hao-Tian, I think, will show that in the demo, right? An example from this notebook is, you take a Google Maps screenshot of some restaurant in Miami, feed it into Gemini Pro Vision, and then you basically specify in the input prompt, I want to extract out like a restaurant, like Pydantic object, and this is the Pydantic object that you get. Great, so we'll show that very shortly. Just some additional use cases on its own is that the whole part about structured output extraction on its own, we've seen a few users just basically do that, right? Forget about the RAG part, just like that in itself is pretty useful. You take, Google Maps, like take product reviews, take basically any sort of art or image, and then you just extract out some sort of structured metadata from it. And basically this gives you just structured annotations, and you can use this for lookup later, or you could just kind of use this to showcase to users, right? And so the whole format is similar to how you do like prompt text completion model to generate structured outputs. You put some stuff on the prompt to tell it to output JSON, like in the text prompt, and then you give it a task and you give the input image, and then you're able to, let's say you have the keys like restaurant, food, location, category, and you give that JSON schema in the text prompt. It'll then output it in the correct format. Another step that we've kind of talked briefly about is, there's kind of some other cool use cases that you can do with multimodal. These things are ever evolving, so we'll probably come up with more. Another is like, instead of kind of like doing intertwined multimodal RAG, one thing you could do is just first, like given the image, try to caption it, right? So first, like just use a multimodal model to generate like a text description from that image. But then if you have like your own text knowledge base, right, you can basically kind of take that caption and make it into something that's more context aware given your data. And so therefore you get a much more detailed response. So let's say, you feed in an image of like a Tesla supercharger. Of course, these days, everybody knows what Tesla was, but imagine if this was just some like unknown kind of vehicle brand, but you generate this description of the image. And then you look up from your private knowledge corpus more details from this brand. You're able to generate a much more comprehensive set of descriptions. Great. And I think with that said, we can probably dive into the notebook. This is pretty much the notebook we'll be going through. And again, we'll share these slides later, so if you miss it, it's totally fine. This was done in collaboration with the Gemini team, along with LlamaIndex, and Hao-Tian will give a short demo of how it works.
Yeah, thanks, Jerry. So yeah, let me share. Yeah, so I'm going to tell about how we integrated with the Gemini model with LlamaIndex. So it opens a lot of opportunity for us, especially for multimodal side. So we have two notebooks, one is for Gemini chat, like the text complete chat. So this is the basic text-based LLM. But for this specific example, I talk more about the multimodal LLM with Gemini, so how we do it. So there are three parts we are going to show how we using the Gemini into the three different settings. So the first part is just simple, like the complete chat and also stream chat complete. So basically ask the Gemini Pro, Vision Pro model some questions. For the second part, I think mostly on the how we using the Gemini to output some structured data from the image. So structured output from image is super important for us, especially for when we want to build a knowledge graph, knowledge base. So those structured data could be useful when we do the index and the retrieval. For third stage, after we get the structured data from image, how we build a RAG, text-based RAG to understand what's the question and what's the best result from the question. Yeah, so this is high level how we build it. And basically what you need is that for the Gemini model, you can access for certain countries and the region. You basically need to install the latest Google Gemini AI package. And also definitely you need to have have your own Google API key. So you can easily apply for the Google API key from the Google, like the Gemini AI website. So this is the LlamaIndex part. So we already integrate some abstraction and also classes for the Gemini multimodal class. So the first thing is that it's very simple. So basically, given a Gemini Pro model, Vision Pro model, we can load some image URLs, or we can also do the local images. So basically, we ask a question for this image, right? So this is the image we are going to show in the example. So basically, this is a New York City like view in somewhere. And the question is very simple. So identify the city where the photo is taken. So basically the answer is pretty short. So it's New York City. Give me the correct answer. And also definitely we can do a lot of stream complete. Basically we can answer the question in the stream model and also async complete. So these are all the features we are right now supporting from LlamaIndex side with Gemini. And also definitely because Gemini can take multiple images into the chat and also complete. So there are some examples I can quickly share with you what the image look like. So the first image is like Messi. So it's holding like the football cup. The second image is I think is from the Roma, Italy. So the famous places to visit, right? So basically the question is that, can you give me some correlation relationship between those two images? So Gemini can take multiple image into the consideration and give us results. Right. So second part is that how we leverage the Gemini, the power of the multimodal, especially image reasoning part to understand the image. So Jerry already briefly mentioned the example in the slides. So what we want to do is that, so these are the models we have right now from my API. And we basically have some Google restaurant images. So we crawl from the Google website. So I just randomly pick several restaurants. So this is restaurant information I want to know beforehand. So this is structure input for the Pydantic object. So those information, those structure input will be very useful if you want to build some simple recommendation search index and also recommendation system, right? So beforehand, we want to know what's for this restaurant from Google Map. What comes the information attribution we want, for example, restaurant, the food, location, category. But one thing I want to highlight is here, because this is the screenshot. It's not very clear, I think, but you can tell is that it's some restaurant in Miami. But one more question attribution I'm asking Gemini is that you can see here there's a park nearby the restaurant. So we not only can get the text from the Google Map, but also we want to let the Gemini to understand the Google Map, the image. So there's a nearby, like I cannot tell the name, but it's a key park somewhere near the restaurant. I'm asking the Google, can you also give me the nearby tourist places, right? So if I want to go to a restaurant, I also want to know what's the nearby tourist places I can visit. So can give me a recommendation for the Google restaurant. And after we generate, for example, the first Pydantic, like the structure input, so this is the input class, and also we're showing the Gemini LLM. So Gemini LLM is a multi-modal provision model. And then we run the program. So there is a Pythonic program. Then and also definitely we have multiple images. We want to test, for example, Miami, Orlando, Toronto, whatever you can name. But you can see the results here. So I just print out Miami, the example one. So here is a restaurant, food, location, pricing, everything. And also surprisingly for the nearby tourist place, it can give me the correct answer, the brick tail key part, right? So basically this can tell us more information beyond the text from it's not simple OCR, but also some understanding what's exactly on the Google Map image. And yeah, so this is basically how we do the second step. Basically, we extract a predefined structure class attribution from the Google image. It can give me very good results. And after we have those information, basically we can build our index knowledge base, right? So we can leverage those information. You can imagine this as a metadata for this image. We can throw in the RAG system. So for recommendation, I just build a simple RAG retrieval and recommendation system using those kind of information. So this is a nodes basically for every document in the LlamaIndex, we call nodes. So basically we give some metadata for according to the attribution we extract. And also the text are using the description of the restaurant as the main text. Then we are building the simple like the vector store and the vector index. So basically this is the vector DB. And also we are integrating with the Gemini embedding. So Gemini also released the embedding model. So, but right now I think it's only text-based. So basically we are using Gemini embedding to do the encoder for the text. And for the query engine, we also have query engine. So basically for LLM, we are also using the Gemini Pro as a LLM model. So basically let the Gemini LLM to understand what the question is, what's the information from index to final re-rank and synthesize the final results. So this is how we build the index and also the survey context side, basically LLM embedding side. After we build the index, the text index from the metadata from the image, now we can simply build a query engine. So according to the images we already encoded, extract the information, restaurant description, title, pricing, whatever from restaurant. Let's ask a question, recommend me a Orlando restaurant for me and also its nearby tourist place, right? Because from the metadata, we already extract those information from the image from Gemini. And the results is pretty good. So this is, those are the message part for my debug usage. But if you look at the final results, you can say, oh, for the delightful dining experience, the Mayo restaurant, known for its American cuisine, so it's located somewhere in Orlando, and also it's nearby has a Universal Studio, right? So if you text a dinner there, you can also use a Universal Studio like tourist places. So this is how we can simply leverage Gemini's multimodal ability to enable us to do more, not only text, but also can enrich our RAG system using the image structure output. Yeah, so that's my part. Yeah, so welcome any questions.
Great. I'm trying to check to see if there's any questions. Okay, a lot of questions have asked about the notebook. But I think we shared the links in the chat. I think maybe one high-level question is maybe just to get your guys' thought, like when doing multimodal, is there a way to kind of, or for Haotian specifically, is there a way to check if text and images are associated or not, kind of like a reliability score? Like if you want to actually look at the return results in terms of both text and images.
Yeah, so there's something advanced features we plan to add. So basically, we are retrieve a bunch of text and images, right? For example, for Google review, sometimes the text only provide limited information for a restaurant, but image can tell more about the restaurant itself. So when we do final re-ranking and synthesizing, so basically we can somehow using their embedding score or using some score to verify whether those image or text retrieved are relevant to this query. Right? We can also ask LLM if you think LLM call is super expensive, maybe it's not that super expensive for you. You can directly ask Gemini LLM, hey, give me those context, image, and also text. Can you answer the question using the Google latest like the AQA system, right? So basically, I think when we do the multimodal, I want to mention that there are some cases only the image or text cannot cover all the information. So combine both of them will give us better comprehensive results. But definitely we need to do some threshold checking whether those information are relevant or comprehensive to answer the question. Yeah.
Cool, makes sense. And then next question is, could you maybe just explain again how the structured data extraction works? I think one of the questions is about how do you actually prompt the Gemini to output a Pydantic object?
The Pydantic is a program. So basically, in the example I already showed you, so basically we need to predefine the Pydantic class object for the structured output, right? So basically in the backend we ask a prompt. So can you, for this image, can you answer me a JSON format from this image? It may cover all the information in the Pydantic class. Then we're passing the output from Gemini according to those attribution. So basically we extract the attribution results from the response and fulfill the response. So this is how we do high level in the backend, how we deal with this. But for easy thing, you don't need, using Pydantic is the thing that you don't need to ask the Gemini directly, can you answer me a JSON format? We can automatically convert the JSON format for you and also fulfill the attribution. Yeah.
Yeah, so what Hao-Tian is saying is we have abstractions in LlamaIndex where basically you don't really need to worry about how you prompt Gemini. We just kind of handle that for you because we prompt Gemini, and basically the underlying prompt just says something like, here's the Pydantic schema, and you can do model dot, I think schema parentheses, and it'll just dump the JSON format, and then basically Gemini provision and Gemini is just responsible for, given that schema, try to make sure that the output actually conforms to it. Right, so it's not guaranteed to be correct, but it actually turns out it does a pretty good job. And I think this is a pretty popular approach for just generally how you extract structured outputs. Maybe one kind of final question and this is actually for the Google Labs team. There's kind of two things in terms of kind of future directions for Gemini actually. And feel free to just call out if you don't actually know the answer. Are you going to add support for fine-tuning Gemini? For instance, so that you can actually improve capabilities?
Yeah, we're open to developer feedback in that area. So let us know if that's something you're particularly interested in.
Cool. And can you actually process stuff beyond the images like video and audio? Yeah. Don't worry. Yeah. If you can't publicly share, that's okay too.
Yeah, I don't know right now.
Okay. Sounds good. Cool. I think that's most of the questions. Okay, so I think for the audience, you basically saw a two-part workshop, one on the kind of semantic retrieval side and the other on the multimodal side. And so basically kind of this workshop hopefully gave you a flavor of how to do that with Google Gemini as well as Provision. And so these videos will be up on YouTube. Hope it was a fun experience. And thank you again to the Google Labs team for coming to join us. All right, take care and happy holidays.